This is a third example problem, finding product of inertia for a composite area made up of several different subshapes. This is the shape. It's made up of a rectangle, a right triangle, a half circle, and a hole. And so how do we handle these situations? We already found the moments of inertia. We're not looking for those. We're just going to do product of inertia here. Again, this is our product of inertia for the shape. About the XY axis, we're going to use the parallel axis theorem. It's the sum of I bar about the centroidal axes of each subshape plus its area times its dx times its dy. Just think, planning out our strategy. We've got a rectangle, a right triangle, a half circle, and a hole. So our I bar is going to be 0 for the rectangle, for the right triangle, and for the half circle. We have a right triangle at this orientation. And so if you look at that orientation, that's a negative sign at that orientation. And so it's a negative 1/72 b squared h squared at that orientation. And so negative 1/72 6 squared times 3 squared is negative 4.5. For the rectangle, because the rectangle is at the origin, I can use the I origin form for a rectangle, which is this corner here, and it's 1/4 b squared h squared, and it's positive. So it's 1/4 6 squared 4 squared, which is 144 for that guy. So the IXY is the sum of the I bar plus a dx d squared. For the rectangle, we already determined the I origin formula. It's 144. For the right triangle, we said his I bar is negative 4.5. His area is 1/2 of base times height, so 1/2 of 6 times 3. The dx from the y-axis to his centroid is 1/3 of 6, which is 2, positive 2. And his dy, which is from the x-axis up to this, is 4 plus 1, which is 5. So we have 2 and 5. For our half circle, his I bar is 0. His area is pi r squared over 2. His dx, the distance from the y-axis to his centroid, is 6 plus 4r over 3 pi. So 4 times 2 divided by 3 pi, which is 6.8488. And then his dy is the distance from the x-axis up to his centroid, and that's 2, positive 2 for his dy. And so that's the half circular area. And then the hole, we subtract the hole. So we subtract the I bar for the hole is 0. The area of the hole is pi r squared. The dx for the hole is 6. The dy for the hole is 2, both positive. So 6 and 2. If you compute these terms, you basically get an IXY is 277.9 centimeters to the fourth. It's positive, and you would expect it to be positive. So it's an area in quadrant 1, and so you expect that IXY to be positive, and it is.